Hey everybody, this is Larry doing the 30-day Leetcode challenge. This is day 8, and it seems like we have a new problem, so let's get to it. Uh, for the new viewers, I am actually doing these live, so that's why it's a little bit slow on the explanation, but bear with me, let me know what you think, and hit the like button, subscribe button, whatever. Okay, the first problem of week 2, middle of the linked list. Given a non-empty singly linked list with a head, return a middle node of the linked list. If there are two middle nodes, return the second middle node. Okay. So there are a couple of things I thought about immediately. Uh, One is whether there's just edge cases or like weird cases in general, like if there's a loop or something like that, and that actually maybe a little bit of a hint to this problem and you might have to handle it well. And the second thing that I would look at least for competitive programming, is kind of look at the input and the example cases, just to kind of see, like how detailed the example cases are. So would I have to create my own test cases, right? And in here, there are some obvious ones, like the even number of nodes and the odd number of nodes, um, because sometimes they don't always give you all the examples, and then you find out the hard way that you're wrong. Um, so yeah, so the well, one is n, where the n is the number of nodes. It's only up to 100, so you could do things pretty much as inefficient as you like. If you're doing this on an interview, I probably wouldn't recommend it, and would at least think about it a little bit, especially since you have 45 minutes. So my first thought would be to just do it naively, and it's probably the way to go in terms of writing non-error prone code, uh, because you just go for the loop and then you get the number n, and then you just go for the loop again for n divided by 2, right? Plus minus 1 or something like that. But what I will do is that think about that edge case with the loop. Actually reminds me of another algorithm called one of Freud's algorithm, uh, which is the um, the turtle and the rabbit, or the hare and the tortoise, or something like that. But the idea there, and this is actually helpful for finding cycles in finding a cycle in in a linked list, and this is actually like ties into what a previous problem we did on week 1, the happy number, where you're trying to see if it terminates, right? So you could do it that way, and using that same logic, and there's a link below. Probably I could do that for the video to happy number, or you could just do a Google search. Happy numbers are actually a well-known thing, um, and then from that the idea is just have 2 pointers, one that moves 2 ahead, and then one pointer that moves a slower pointer that moves 1 pointer or 1 node ahead, and then when the faster pointer gets to the end of the list, then because because the slower pointer is moving 1 node for every 2 nodes that the faster pointer is moving, then when the faster pointer gets to the end of the list, the slower pointer will be at the middle, right? So let's play with that, since that's more fun to think about. Maybe on an interview I would not do it necessarily, because you don't want to pretend you're smart and then make a silly mistake, and then your interview is like but but I might still talk about it, because I don't know, it's interesting. I like to communicate as much as possible to let the interviewer know what's in your head, within you know reasonable time constraints. Okay, cool. So let's kind of get started. So I just say if there's a faster node, is you go to head. Slower is also you go to head in the beginning, and then um, and I think we just have to kind of think about the edge cases, but we could play around with it. It's going to be at most off by 1. Um, so yeah, wow. So how fast is not none? So have to be a little bit careful, because you want to write like something like this. Dot was it dot next, but obviously you have to like no check. Um, so yeah, so let's do that. Oops. And then let's do it again. And then do that to the slow one. Though I think this, you could reason to yourself and prove that this is actually not necessary, but I think I just like to keep the code symmetric. So this may actually be off by 1, but let's kind of take a look, at least for the even case, or one of the cases. Then also put in the second example while we wait for the judging, which today seems to be a little bit slower than a couple of days previously. Oh, well, okay. So actually, I was wrong on this one because then it would just never terminate. So, okay. But we need to do it at least once just so that, because if you do faster than next, then it would just give you the equivalent of a no pointer exception. I forget what it's called. Just like object not undefined or something like that in Python. Yeah, okay. So actually that worked pretty much I mean, there's a civilization, they tell you that's well. So that pretty much worked directly. Let's quick a submit just to see. I mean, usually I would advocate for more test cases, and I think that maybe the obvious one is just one node. But beyond the and 2 nodes, I guess. But beyond that, I don't know. Those are probably general enough that that goes for all of them. Like if it passes for these two, then it probably should be okay. Oh, well, so it does not pass for one case. How do I want to write it? Okay, also, actually, I was just wrong in general because I misread the entity of the output. So yeah, so we were off by 1. Mm-hmm. Did I change something? Maybe I just read. Sorry, I just maybe read something incorrectly. Did it work? Okay, but it just seems like we moved to the next one a little bit too aggressively, so we just have to be a little bit careful. Um, oh, I see. Because we don't start. So the off by 1 here is that because we start at the head, um, it's almost like it's it's funny because it's almost like the difference between 0 index and 1 index, and because we start at the head, we started at the 0 index, so when we move 2, we actually go to the third one instead. So that's why there's an off by 1. Um, hmm. So what is a way to solve this? So I'm going to create a sender value to kind of fix this. Um, but maybe there's I mean, so the way that I'm doing this is so that I don't have to consider as many new cases or edge cases. Um, but definitely, you can, do a case analysis of this, and then that'll be okay. Let's run the test again. Okay, now it looks okay, right? So now let's submit it. And as I said before, I'm confident that these tests are representative of the entire tests, unless there are loops or something like that. So yeah, so here we go, we accept it. Cool. That took me a little bit. I think, yeah, it's a very fun, interesting problem. And as I said again, maybe on an interview, I would not try to show off as much and just do something like, you know, like maybe my interview code would be, at least, unless the interviewer asks after I do this very quickly, like, n is 0, while head head is not none, head, oh, I guess it's just pointer. So I would do something like this. the same thing in typos. And then now, and then also something like, so this may be off by 1, and this is where we would test it, but yeah, so I think that is actually maybe right, but maybe off by 1. But that's the idea that behind how I would do it if I did an interview, just so that I don't, because there are more potential, especially if when you're writing an algorithm that you might not be as familiar and comfortable with. There may be more edge cases that you may not consider. So, and here, it does seem to have fewer edge cases other than the off by 1. So, maybe, well, go with your heart, go with your gut, go with your intuition. That's where I would say. But that's how I would think about this problem. And thanks for watching, I think. And hit the like button, subscribe button, all that stuff. Thank you.